Hey students, let's do a couple of wave practice problems. So I'm going to show two different types of wave problems that we're going to do. One of them will use our new wave equation where velocity equals frequency times wavelength, right? That's our wave equation. And then we can also use our other older equation, velocity is displacement divided by time. Depending on how the wave problem is set up, the wave equation that we just mentioned might be easier to use, or using the older velocity equals distance over time, that equation sometimes is easier to use, particularly if you have a type of problem that involves echoes. So what I'm going to do is I'm going to put the first question up on the screen, and then I'll walk you through how to do that.
All right, let's do a wave problem or two. So let's first talk about how we do the wave problems, because we have a wave equation, and the wave equation looks like this. It says that the wave speed, which is v, is frequency times wavelength. And wavelength is abbreviated with this symbol right here. This is a lambda. Right? So it's a Greek letter, and we use that to represent wavelength. Most of the time, if we're doing wave problems, we can use our wave equation over here. But sometimes, depending on the way the problem is worded, you can just use our old friend, velocity is distance over time, right? And that'll work just fine. So that's another option for us. This, as you notice, has three variables. So we can do our triangle trick. And if we do our triangle trick, velocity goes up here, and we have frequency and wavelength on the bottom. So that's one option that we can do for our wave problems. The other one is we can use velocity is just our distance, or really displacement if it's velocity, divided by time. And again, we can still use our triangle trick. And we've got our distance, we've got our velocity, and then we have our time down here. So what we're going to do is we're going to do a couple of different practice problems, and I'm going to show you the first one right now. Okay, so that first wave problem, we've got the speed of sound is 342 meters per second, and the frequency has been measured to be 560 hertz. We want to find out what the wavelength is. So let's do that first problem right under here. We'll just label this one number 1. So it says that our velocity, right, the speed of this wave, which is the speed of sound, 342 meters per second, it has a frequency of 560 hertz. And what we want to do is we want to find what is the wavelength, right? What is lambda? So our equation for the waves is velocity is frequency times wavelength, and you can see that this equation is going to fit, right? This equation right here will fit because we have all of our variables that match the equation that's listed here. I do need to do a little bit of algebra or use the triangle trick, which we have at the top up there. So I need to rewrite this so it reads lambda equals. So the triangle trick says that lambda, right up here, would be equal to velocity over our frequency. So that's what I'm going to write. Velocity over frequency. And it's this equation that we've got written here that solves this problem. So now let's put the numbers in. So we've got our 342 meters per second, and we're going to divide that by our 560 hertz. The calculator does all the work for you. You just put those numbers in. 0.61 meters is the answer that we get for this practice problem. Let's try one more. I'm going to put one more practice problem on the screen. You take a look and read that, and then we'll work on that one together. Okay, so this last problem that we're going to do, our second problem, that's the wrong color. It's a little bit different from this one. There is a way that you could do it like this one, but I'm going to show you another way. So for this one, we've got a bat, right? And a bat uses echolocation, which is basically just a fancy way of saying that the bat will squeak, the sound waves will go out, they'll bounce off of some obstacle, and then they'll come back, right? And it says that when he squeaks, 0.5 seconds later, he can hear the echo, and we want to figure out how far away is the object. And what we'll do is we'll use the same velocity, the same speed of sound that we had in the first problem for the second one. And what happens is, I'm going to draw a little diagram here. This is going to probably be terrible. This is going to be my version of a bat. Look how terrible that is. There we go. It's got little feet. Make it a happy bat. And so there's some obstacle that's over here. And what happens is the bat will squeak and these sound waves will go out like this in this direction. Boom, they'll hit this obstacle and then they'll rebound and they'll come back to the bat's ears. So what happens is that the sound goes in this direction, hits the object, and then it comes back again. And so what it's basically done is it's traveled this distance once, twice. So how do we fix that? Well, it takes a certain amount of time to go there and to come back again. And so that's one complete cycle, which is what we call period. So I'm going to call this the period of the echo. Let's call it techo. And so that was 0.5 seconds. So that's going to be helpful, but what we want to do is we want to figure out what is the total distance away that object is. Now we can't use this 0.5 seconds right here because the 0.5 seconds was how long it took to go that distance, not once, but twice. So what I'm going to do, let me just move this down a little bit. I need to find out what is the time that it took to travel that distance once. And the way that I do that is I take my echo time and I just divide it by 2. So I'll have my 0.5 seconds divided by 2. And that gives me 1/4 of a second. And now I can use that to figure out the distance. So what we can do then is we can say it took 0.25 seconds to go this way, and then it took another 0.25 seconds to come back. Now, if we look at the information that we've got listed over here, I've got velocity, distance, and time. And so for this problem, it looks like this older equation that we've been using is probably going to make a little bit more sense. Right? So I can write that velocity is distance divided by time. And using the triangle trick that we've used in the past up here, or a little bit of algebra, we rewrite this so it's distance equals velocity multiplied by time. So for this problem, we don't have to use the wave equation, even though it is technically a wave problem. That's the workaround for this one. So we'll use our same 342 meters per second. That's the speed of sound for this problem. And now we're going to use the 0.25 seconds for the time. And when we multiply those together, we get 85.5 meters. So this object is just about 86 meters in front of our bat over here. So that's 2 examples of how you can do a couple of different wave problems. So give the rest of those a try and let me know if you have any questions.